Know that fish can recognize human faces and even remember who feeds them. That's right. These aquatic creatures are far more cognitively advanced than the old myth of a 3-second memory would suggest. In reality, numerous fish species have demonstrated the ability to remember individuals, both human and fish, over extended periods. For instance, archerfish can be trained to distinguish between different human faces, a skill that requires complex visual processing and long-term memory. Some fish in home aquariums swim excitedly toward familiar humans who regularly feed them, demonstrating recognition and learned association, much like a dog wagging its tail. Beyond mere memory, many fish are capable of intricate learning. They remember landmarks, navigate mazes, recognize patterns, and even avoid places where they've experienced danger. Species like cichlids and goldfish have been observed retaining information for months. Wild salmon, during their epic migrations, return to their birthplace years later with astonishing precision, guided by olfactory memory and environmental cues. These are not mindless drifters. They are navigators, capable of forming complex mental maps. Some fish, believe it or not, form lasting social bonds. Like humans, they show preferences for specific companions. They have friends. Studies on damselfish and guppies reveal they choose to swim and cooperate with certain individuals over others. In some cases, bonded pairs or social groups defend territory together, forage side by side, and even engage in mutual grooming behaviors. And yes, fish can dream. Neuroscientific studies have found that during periods of rest, certain species exhibit brainwave patterns that resemble the REM, rapid eye movement, sleep found in mammals, the stage of sleep associated with dreaming. Zebra danios, for instance, enter states where their neurons fire in rhythmic bursts while they remain motionless. This opens up profound questions about what kind of mental life fish might have. What do they experience when they sleep? What's more, some fish use tools, a behavior once thought to be exclusive to intelligent mammals and birds. The wrasse, for example, picks up shellfish and repeatedly smashes them against rocks to crack them open. This isn't just instinctual pecking, it's a problem-solving act. Fish like this demonstrate foresight, planning, and an understanding of cause and effect, cornerstones of creative intelligence. Then there are the walking fish. The batfish uses its modified fins-like stubby limbs to walk across the sea floor. The mudskipper, even more astonishingly, can leave the water entirely, walking and hopping across land using its pectoral fins and strong tail. The mangrove killifish not only survives on land for days but also climbs the roots of mangrove trees and hides in moist hollows, breathing through its skin and mouth lining when gills won't do. These adaptations blur the line between aquatic and terrestrial life, evidence of evolution in motion. The archerfish takes aim at insects above the waterline and shoots precise jets of water to knock them down. Their aim is so accurate that they can adjust for the angle of refraction between air and water, a complex calculation involving physics and timing. It's not just remarkable, it's sniper-level precision from a creature with no hands and no scope. Fish are also masters of transformation. The clownfish, for instance, is born male but can switch to female if the dominant female in a group dies. This change involves restructuring organs and hormonal shifts. Wrasses and parrotfish go even further. They can change sex multiple times in their life depending on social dynamics and the needs of their group. In these societies, biology is fluid and adaptive. And in the case of seahorses, it's the male that carries the developing embryos in a brood pouch, a rare and tender reversal of traditional reproductive roles. Many fish are equipped with electrical abilities. Electric eels can generate shocks of over 600 volts, enough to stun prey or deter threats. But not all use electricity offensively. Species like the elephant nose fish generate weak electric fields that they use for communication and navigation, especially in murky waters where visibility is poor. They send pulses and read distortions, effectively, feeling their surroundings and talking in pulses like underwater Morse code. When it comes to size, fish range from microscopic to massive. The whale shark, Earth's largest fish, can grow over 60 feet long, a gentle giant that feeds on plankton. On the other extreme, the Paedocyprus, native to peat swamps in Southeast Asia, is barely 8 millimeters long, small enough to live between grains of sand. Between these extremes lie oddities like the goblin shark, with its protruding jaw, or the barrel-eye fish, which has a transparent head revealing its internal organs and rotating eyes. The ocean is full of creatures so alien they seem born from science fiction. Some fish glow in the dark. Bioluminescence, caused by chemical reactions or symbiotic bacteria, allows them to light up the ocean's pitch-black depths. The anglerfish, perhaps the most famous example, dangles a luminous lure from its head to tempt unsuspecting prey. Others use bioluminescence to communicate, attract mates, confuse predators, or coordinate group movements. It's a light show in total darkness, evolution's own version of neon. And yes, some fish fly. Flying fish have elongated pectoral fins that allow them to glide above the water for distances of over 200 meters, escaping predators by taking to the air. In contrast, lungfish breathe air. Found in Africa, South America, and Australia, these ancient survivors can estivate, a hibernation-like state, for months, even years, buried in mud during droughts. They await the rains, holding on to life with lungs inherited from their prehistoric ancestors. In icy polar waters, some fish have evolved antifreeze. Arctic cod and Antarctic icefish produce glycoproteins that prevent their blood from freezing, allowing them to survive in temperatures that would turn most fish to ice. And in the crushing depths of the ocean, where light never reaches, male anglerfish permanently attach themselves to females, fusing into their bodies and sharing blood, becoming little more than sperm-producing appendages. It's a bizarre but effective evolutionary solution to finding a mate in a near-empty world. Fish communicate in ways we're still uncovering. They use color, posture, movement, vibration, and even chemical signals to send messages. A male betta flaring his gills, a cuttlefish shifting patterns, or a pufferfish inflating like a beach ball are all examples of complex signaling. Some fish are venomous, others poisonous, and a few, like the stonefish, can be deadly if stepped on, hiding in plain sight on the ocean floor like a mine. Consider the sunfish mola mola, which can weigh more than 2,000 kilograms and look like a floating pancake. Or the unicorn fish, with its horn-like protrusion. Or the mighty arapaima of the Amazon, a fish that can grow 10 feet long and gulp air from the surface, adapted to life in oxygen-starved water. Many fish are architects and parents. Male pufferfish create huge, intricate sand patterns to attract mates. Some cichlids dig craters, others build bubble nests or use leaves, rocks, and shells to protect their young. In cold climates, fish have been found frozen in solid ice during winter, only to thaw and swim away come spring. Nature has given them the gift of suspended animation. Even tropical paradise has a secret. That fine white sand. It's often parrotfish poop. These colorful fish eat algae-covered coral, grind it up with their strong beaks, and excrete it as soft, white sand. A single parrotfish can produce hundreds of pounds of sand per year. So next time you're lying on a beach, thank a fish for your blanket. Fish feel, too. They experience pain, fear, and stress. Their cortisol levels spike when injured or threatened. They learn from negative experiences and exhibit signs of depression in captivity, especially when deprived of mental stimulation or companionship. These are sentient beings with emotional depth we're only beginning to grasp. Some fish are territorial defenders, guarding their patch of reef or riverbed with impressive ferocity. Others are social synchronizers, swimming in tightly coordinated schools that confuse predators and reduce individual risk, like underwater murmuration. They can also be immensely long-lived. Some koi have reportedly lived over 200 years, and the Greenland shark may live for over 4 centuries. Meanwhile, underwater artists like the male Japanese pufferfish carve vast, symmetrical circles in the sand to woo females, masterpieces that disappear with the tides. Believe it or not, fish can have regional accents. Research has found that populations of the same species produce different vocalizations depending on where they live, variations shaped by local conditions, much like dialects in human language. Cleaner fish are essential to ocean health. These tiny workers remove parasites from larger fish, including sharks, who patiently line up and wait their turn at natural, cleaning stations. It's a marine spa with rules, cooperation, and surprising civility. In the end, fish are not simple. They camouflage, communicate, build, hunt, plan, nurture, glow, shock, adapt, dream, migrate, defend, and perform astonishing feats of survival and ingenuity. They're engineers of the deep, artists of the reef, and explorers of their own mysterious world. So the next time you look into an aquarium, or peer into a tide pool, or see a shimmering shape beneath the waves, pause. You might be witnessing one of the most sophisticated, beautiful, and mind-blowing lifeforms on the planet. We've only just begun to understand them.